Hello, welcome to today. We're going to learn about arithmetic sequences. And we're going to take a look at series the next day, okay, on the next night. Now, an arithmetic sequence. Now, we've talked about sequences before. These are just any numbers that have a pattern to them. And today we're going to take a look at a special pattern called arithmetic. Now, an arithmetic sequence is a term whose terms increase or decrease, sorry about that, by a common difference that we call D. And let's take a look at a couple of examples right down here. Let's look at number 1, for instance. I'm going from 1 to 2 to 3 to 4 to 5. This is a perfect example of an arithmetic sequence. If we notice, each one of these from one term to the next term is just increasing by 1. So therefore, this is arithmetic. What's the common difference? Well, the common difference is I'm just adding 1 each time. So we say the common difference, D, is 1. So let's try number 2 here. Is this arithmetic? Yeah, I keep adding 2 on top. And on the bottom, I'm not really adding anything, right? So if you think about this, this is just adding 2/4 each time, which is 1/2. So we keep adding 1/2. So therefore, D here is 1/2. See if you can try number 3. See if you can find out what the common difference is for number 3. Shouldn't take you too long. And then let's go down here real quick. So pause if you need to. And let's take a look at down here. Determine the following are arithmetic. So to determine something arithmetic, we're looking for a common difference. So we look for a common difference. And how do we get a common difference? Very simple. I take the next term, multiply by add or subtract it from the previous term. So I'm going to take 8 minus 5. That's 3. Take 11 minus 8. That's 3. 14 minus 11. That's 3. 17 minus 14. That's 3. And see all these right there? The common difference. Now, we don't normally show it this way. I'll show you where we normally show it in just a second. There's our common difference. Therefore, this is arithmetic. What's D? 3, the common difference. So let's try number 2. Well, if I take 4 minus 2, that's 2. That's cool. But if I do 8 minus 4, that's 4. Notice, not the same. We want them to be the same. Hence the phrase common difference. Therefore, this is not arithmetic. Take a look at number 3 here. Now for number 3, I'm going to rewrite this because they all look terrible. Use a common fraction. 1 becomes 6 over 6. 7 over 6. Put that over 6. I get 8 over 6. This becomes, 9 over 6 and 10 over 6. And here's how we normally show a common difference. ... Subtract. 7 minus 6, I get 1/6. 1/6. 1/6. 1/6. Notice, these are all the same. Therefore, this is arithmetic. And if it's arithmetic, what's the common difference? 1/6. Easy to do. Let's take a look at number 4 now. Now, for number 4, common difference, 3 minus 1 is 2. 5 minus 3 is 2. So far, we would say, hey, that's arithmetic. But look what happens next. 9 minus 5 is 4. Not equal. Well, not equal, just not equal. There we go. Therefore, not arithmetic. Easy breezy. So let's try this one. Now, number 5, I didn't give you the terms. We're going to have to generate it. And this is called this is called the explicit form. So we're going to generate it. A sub 1, that's easy enough to do. 3 minus 2 is 1. A sub 2 becomes 6 minus 2, which is 4. A sub 3 becomes 9 minus 2, which is 7. A sub 4, which is 12 minus 2, which is 10. Notice, when I subtract them, they all become 3. They are equal. Are equal. Therefore, this is arithmetic. What's D? 3. Very easy to do. So see if you can try number 6 on your own, okay? And then write this down. Okay, so for arithmetic, here's our rule. For anything arithmetic, for it to be an arithmetic sequence, we either add or subtract the same number. Hence the phrase is called a common difference. Okay? So we work these a few. If you need to, then go on to the back page, okay? Because we're about to start that right now. Now, next we're going to take a look at how to write an arithmetic sequence. Now, if you know that a sequence is arithmetic, we can write an arithmetic sequence by using the following formula. A sub n equals a sub 1 plus d, the common difference, times n minus 1. And I explain what they mean right here. A sub 1 is our first term. N is the number of terms. It's a term number. D is our common difference. A sub n, that's the next term. This is our explicit function. The other day we were writing these, okay? But now we're going to learn a rule if it's arithmetic. So we want to write a formula for the following arithmetic sequences. Most of the time it's just plug and chug. Oh, look, they gave me my first term. A sub n, it says, is my first term plus d, which is 2, n minus 1. Now, one thing I want you guys to notice about d before we continue on. This is a linear function. It's linear. D is actually acting like slope. And when we get to number 6, we're going to talk about that, okay? So, here's my answer. I can leave it like this, or if I want to get fancy, I can simplify it. Distribute to 2, I get 2n. Be careful, that's minus 2, minus 6, minus 8. So you can write it either way. Let's try number 2. A sub n equals my first term, 4/3. It's plus a negative 3, n minus 1. And you can leave your answer like this because it's fractions. We don't want to mess with those. Let's try number 3 here. Okay? To get number 3, what's my a sub n? My first term is 2 plus my common difference, 4/5, n minus 1. And if you want to simplify, you can. A sub n equals 2 plus 4/5 n minus 4/5, common denominator, which will equal 4 over 5n minus or plus 6 over 5. And you can simplify it if you want to. We sometimes like this because you can see it as being slope of a line. All right, so let's take a quick look at number 4 now. Now for number 4, if you notice, they didn't give me a function. They didn't give me the parts here. I actually have to find them. Now they did give me my first term as 20, but what they don't give me is d. We have to find the common difference. So how do we do that? Well, in this case it's actually pretty easy, right? I'm subtracting 10 each time. So therefore, d is negative 10. And I correct my equation. A sub n equals my first term minus is plus or minus 10 and n minus 1. And you can simplify that. It's kind of fun to do sometimes. Negative 10n. That becomes plus 10 plus 20, so plus 30. And there's our equation right there. Very easy to do. All right. Number 5. Now again for number 5, I'm going to do a common denominator. I'm just going to rewrite this one, 5 over 5. They again give me my first term, 1/5. But what they don't give me is my common difference again. So I have to find that. What am I doing? Oh yeah, I'm adding 4/5 each time. So there's my common difference, 4/5. And when I write my equation, my first term, 1/5, plus my common difference, 4/5, n minus 1. And if you want to get fancy, you can go back and actually compute all that stuff, okay? All right. Very good. Now, for number 6, this is where it gets a little bit trickier, okay? Because if you notice, they give us our first term, but they don't give me any of the pattern. They don't give me the d, the common difference. They don't give me any of that stuff. So what we have to do is find it. Now, they give me the first term is 1. We need to find the common difference. So how do we do that? Well, to do that, we go back up here. Remember what I said? We can think of the common difference, the d, as slope. Look at the equation here. A sub n equals a sub 1 plus d n minus 1. Solve for d. We're going to get d equals a sub n minus a sub 1 over n minus 1. This is our slope, right? This is our change in a's. This is like y1 minus y2 over x1 minus x2. We plug it in. Our n is 5, a sub 5 minus a sub 1 over 5 minus 1. And I plug it in. Well, what's a sub 5? 9. A sub 1, 1 over 4, and we get 2. D is 2. We already had a sub 1 was 1. Sorry. And now we can write our equation. A sub n equals 1 plus 2n minus 1. And there's our answer. And that's number 6. Okay? Now, take a break right now. Go back and try number 6 if you want to. Then join us for part 2, and we're going to go over the rest of this. Okay? See you then.